Imagine a world where cars no longer need charging stations, gas, or even a plug, where your vehicle powers itself endlessly. Sounds like science fiction? Well, the patents behind Maxwell Chikumbutso's self-powered car suggest it might be closer than we think. Recently, the U.S. patents detailing his method for converting conventional cars into self-sustaining vehicles have been exposed, and the implications are staggering. Maxwell, an inventor from Zimbabwe, has been quietly developing technology that could disrupt the entire automotive industry. His method isn't just about electric motors or batteries. It's about harnessing energy in ways most engineers thought impossible. According to the patents, his system captures ambient energy, converts it efficiently, and feeds it back into the car's drivetrain. The result? A vehicle that theoretically keeps moving without ever needing a recharge. What's even more fascinating is the simplicity and elegance of the design. Unlike the high-cost, heavily engineered solutions from global automakers, Maxwell's blueprint relies on principles rooted in physics that are accessible yet revolutionary. The U.S. patent filings reveal circuits, energy flow mechanisms, and a conversion system that could potentially retrofit existing vehicles, turning any ordinary car into a self-powered machine. Critics have been quick to dismiss the claims as too good to be true, pointing out thermodynamic limitations and efficiency losses. Yet the level of detail in the patents makes it clear this isn't a vague concept. It's a working methodology. Diagrams show how the car's energy circulates, how excess is stored, and how the system maintains stability under load. For anyone obsessed with the future of transportation, it's a glimpse into an alternative reality, where cars are no longer chained to fuel stations or electrical grids. The global ramifications are profound. Imagine Africa, where infrastructure challenges often limit mobility, suddenly having access to vehicles that can self-sustain. Or think about congested urban centers where electric vehicle adoption is slowed by charging limitations. Maxwell's technology, if implemented at scale, could rewrite the rules of transportation, energy distribution, and even environmental impact. Of course, the patents themselves are dense and technical, filled with equations, schematics, and legal jargon, but the essence is simple. Create a feedback loop that captures and reuses energy efficiently. This isn't a perpetual motion machine in the fantastical sense. It's a system designed to minimize waste and maximize energy recovery. And the leaked documents suggest Maxwell isn't just theorizing. Prototypes exist, running on real roads, demonstrating the viability of his approach. Even Tesla, the global leader in electric mobility, would have to take notice. The idea of a car that sustains itself without grid dependence is not just disruptive, it's existentially challenging to the current energy and automotive paradigm. Industry insiders hint that if Maxwell's method can be scaled safely, it could trigger a cascade of innovation, forcing traditional automakers to rethink their models entirely. While skeptics remain vocal, the leaked U.S. patents offer a rare glimpse into what might be the future of personal transportation. The combination of ingenuity, physics, and practical engineering in Maxwell's blueprint hints at a reality where energy scarcity is no longer a limitation for mobility. The question now isn't whether this technology can work, but when the world will witness its first widespread implementation. Imagine stepping into one of Maxwell's self-powered cars. At first glance, it looks like any modern vehicle, sleek, aerodynamic, familiar, but the moment it starts moving, the difference is undeniable. There's no hum of a charging battery, no sputter of a fuel engine, just smooth, uninterrupted motion. Sensors quietly monitor energy flow, while the patented system captures residual energy from braking, friction, and even ambient electromagnetic fields. That energy is then recycled back into the drivetrain, powering the car forward with astonishing efficiency. Engineers who have studied the patents note the brilliance of the modular design. Each component is optimized not just for performance, but for adaptability. The system can, in theory, be retrofitted into existing vehicles, turning ordinary cars, trucks, or even buses into self-sustaining machines. The implications are staggering for transportation in remote areas, disaster zones, or regions with unreliable electricity. Mobility could become universal, unrestricted by infrastructure limitations. But Maxwell's vision isn't limited to just cars. The patents hint at applications for larger vehicles and even public transport systems. Imagine buses in major cities that never stop for fuel, drones that can fly indefinitely, or freight systems that drastically reduce energy costs. The core principle remains the same: capture energy that would normally be wasted, convert it efficiently, and feed it back into motion. It's a subtle but powerful shift in how we think about energy. Of course, translating patents into reality is never straightforward. Maxwell has faced skepticism, regulatory scrutiny, and the inherent technical challenges of scaling a breakthrough technology. Yet reports suggest that prototypes have already been tested on public roads, demonstrating ranges that far exceed conventional EVs without recharging. For the automotive world, this is more than innovation. It's a potential paradigm shift. Industry insiders are quietly watching, knowing that if Maxwell's approach proves commercially viable, it could force a reevaluation of everything from manufacturing to energy infrastructure. Automakers may have to consider self-powered designs, cities might rethink charging networks, and energy companies could see a dramatic shift in demand patterns. The ripple effects could be global. Even more intriguing is the openness of Maxwell's method. Unlike many high-tech innovations locked behind corporate walls, the patents offer a level of transparency that invites collaboration, research, and improvement. It's not just a secretive invention. It's a blueprint for a future where self-sustaining vehicles are accessible and practical. The excitement is palpable among engineers, futurists, and innovators alike. They're dissecting the diagrams, running simulations, and envisioning prototypes. And while challenges remain, efficiency optimization, material costs, regulatory approval, the vision is clear: a world where vehicles generate and sustain their own energy, transforming mobility as we know it. Maxwell's leaked patents have done more than reveal a technology. They've opened a window into a possible future. One where the barriers to transportation are dramatically lowered, energy use is optimized, and human innovation proves once again that limits exist only until someone dares to break them. Picture the car gliding along an open highway at sunset. The dashboard shows no need for charging, yet the energy meters indicate a perfectly balanced flow, recycling and reusing power in real time. Every turn, every brake, every acceleration is accounted for. Nothing is wasted. The car feels alive, almost symbiotic with its environment, pulling energy from the very air and motion around it. As the miles pass, the advantages become undeniable. Unlike conventional EVs that require careful route planning to avoid running out of charge, Maxwell's car simply keeps going. Remote villages, long desert stretches, and mountainous terrains suddenly lose their logistical barriers. A vehicle like this doesn't just transport people, it empowers them. It changes what's possible in travel, commerce, and even emergency response. Engineers testing the system note the subtle genius of the feedback loop. Braking energy, which normally dissipates as heat, is captured and converted. Vibrations and movement from the suspension generate usable electricity. Even the car's own electromagnetic field contributes to the power flow. It's a carefully orchestrated dance of physics and engineering, invisible to the casual observer, but monumental in impact. The car's interior remains surprisingly normal. Seats, infotainment, and safety systems feel familiar, lulling passengers into comfort, while the technology under the hood quietly revolutionizes the experience. From the outside, it might look like any other car, but it's a rolling testament to human ingenuity, silently challenging decades of assumptions about energy and transportation. News of these prototypes has begun to stir conversations in scientific circles and the automotive industry. Some dismiss it as overhyped, others see it as a threat to traditional energy markets. But those who truly understand the patents realize this could be the blueprint for the next generation of transportation. A future where vehicles are independent of external energy sources, where mobility is unbound by infrastructure, and where the world begins to rethink what it means to move freely. As night falls and the headlights cut through the darkness, the car continues its journey, uninterrupted. No stops, no drains, just motion sustained by innovation. In a world still tethered to oil, gas, and charging grids, Maxwell's self-powered system feels almost magical, but it's grounded in hard science, meticulous engineering, and vision. This is more than a vehicle. It's a statement that energy scarcity is not inevitable, that limitations can be overcome, and that one inventor's idea can ripple across the globe, changing industries, economies, and lives. And the story is far from over. Engineers are refining designs, new prototypes are being built, and the possibility of commercial release edges closer. The leaked patents are just the beginning, an invitation to witness a transformation that could redefine personal mobility forever. Imagine a test track somewhere in Zimbabwe. Maxwell's prototype car accelerates smoothly, hugging corners with a precision that belies its unconventional power source. Engineers watch anxiously as the vehicle endures hours of continuous operation. No overheating, no depletion, just steady, consistent performance. Data streams across monitors, showing energy captured from every turn, every vibration, every tiny movement. It's a live demonstration of the patents in action. Word spreads quickly. Journalists, scientists, and tech enthusiasts start showing up, eager to witness this so-called miracle car. Some arrive skeptical, ready to poke holes, but even the harshest critics cannot ignore the results. The car moves continuously, without plugging in, without fuel. Cameras roll as it completes laps, climbs hills, and navigates complex terrain, all while maintaining energy balance in real time. Globally, reactions are electric. Social media explodes with speculation. If this technology scales, what does it mean for Tesla, for oil companies, for governments managing energy grids? Analysts predict disruptions across multiple industries. Imagine logistics companies no longer reliant on diesel, cities reducing strain on electrical infrastructure, and individuals in remote areas gaining unprecedented mobility. Maxwell's invention isn't just a car, it's a potential revolution in how humanity moves. Yet the journey is not without hurdles. Scaling the technology for mass production requires partnerships, investment, and regulatory approval. Industries with vested interests may resist, fearing the disruption to established markets. Intellectual property debates flare as patents become the focal point of both admiration and contention. But each challenge only underscores the magnitude of what Maxwell has achieved, a concept so powerful that it threatens to reshape entire sectors. Meanwhile, engineers continue refining the design. Materials are optimized, energy conversion efficiency improves, and prototype testing expands to different vehicle types. Public fascination grows, with each successful test fueling anticipation for broader implementation. Observers note the elegant simplicity of the system. No complex external infrastructure, no constant maintenance, just a vehicle designed to sustain itself and its passengers indefinitely. As the sun rises over the testing grounds, Maxwell's self-powered car remains in motion. It's more than an experiment. It's a demonstration of possibility. Every mile traveled is proof that conventional limitations can be challenged and perhaps even overcome. The leaked patents, once just documents, are now blueprints for a future where energy independence and sustainable mobility are not just dreams, but achievable realities. The story continues to unfold. Maxwell's vision, grounded in physics and executed with engineering brilliance, is slowly capturing the imagination of the world. From quiet labs to bustling cities, from remote villages to global media coverage, one question dominates conversations. How soon can this technology be integrated into our daily lives? Across continents, the buzz grows. Early prototypes of Maxwell's self-powered car begin appearing in small pilot programs, remote villages in Africa, tech showcases in Europe, and controlled urban trials in Asia. People witness something unprecedented. Cars that require no charging, no refueling, moving continuously under their own internal energy system. For residents in off-grid areas, this is nothing short of transformative. Children can travel to school safely, goods reach markets without delay, and communities experience mobility freedom previously thought impossible. In cities, the impact is just as dramatic. Traffic patterns change when self-powered vehicles enter circulation. less dependence on charging stations, reduced strain on electrical grids, and a visible shift toward energy-efficient travel. Environmental advocates take notice. A car that sustains itself reduces the need for fossil fuels and cuts emissions dramatically. News outlets pick up the story, and soon Maxwell's invention dominates headlines, described as the breakthrough that could redefine the 21st century automobile. Meanwhile, industries that once dominated energy markets are scrambling. Oil companies, EV manufacturers, and traditional automakers realize that the leaked U.S. patents are more than theoretical. They represent a real, scalable alternative to the status quo. Meetings are held in boardrooms across the globe, analyzing the potential disruption. Lobbyists raise concerns, while venture capitalists see opportunity. The world is awakening to the possibility that energy independence is not a distant dream, but a tangible reality. Amid this upheaval, Maxwell and his team continue refining the technology. Data from field tests informs design improvements, energy capture systems become more efficient, energy flow is optimized, and the vehicles demonstrate longer ranges, with even less maintenance. Engineers explore applications beyond cars: buses, trucks, delivery drones, and even small aircraft. Each prototype proves the core principle remains solid. Energy that was once wasted can be captured, converted, and reused to sustain motion. Public fascination reaches a fever pitch when viral footage shows a Maxwell self-powered car completing a multi-day journey without a single recharge or refuel. Viewers around the world are captivated by this seamless performance: mountains climbed, highways crossed, remote terrains traversed. Skeptics are challenged to reconcile the evidence with their assumptions. The narrative of limitation and dependency begins to unravel. But as momentum builds, so do the stakes. Regulatory bodies start to demand testing protocols and safety certifications. Competing companies look for ways to challenge patents or to replicate the technology themselves. The tension between innovation and entrenched systems grows, making Maxwell's journey not just a story of invention, but a story of perseverance, strategy, and vision. The car itself, silent yet unstoppable, continues its journey, an embodiment of possibility. Each mile it covers tells a story of ingenuity, of science pushed to its limits, and of a future where humans no longer rely solely on external energy sources to move through the world. Maxwell's blueprint, once hidden in patent filings, has now become a living experiment in redefining mobility on a global scale. As momentum builds, Maxwell finds himself at the center of a global crossroads. Governments, corporations, and innovators all watch closely, recognizing that the self-powered car is not merely a novelty, it's a challenge to decades of infrastructure, investment, and conventional thinking. High-level meetings are held behind closed doors, discussing regulations, safety standards, and potential restrictions, while in parallel, engineers and enthusiasts worldwide attempt to understand, replicate, or improve the technology. In the streets, the cars are becoming impossible to ignore. Commuters stare in amazement as vehicles glide past without ever needing a plug or a pump. Public transportation pilots are launched, demonstrating self-powered buses ferrying passengers across cities for days without stopping. Delivery fleets begin small-scale testing, showing that goods can reach even the most remote regions without a dependency on electricity or diesel. Headlines scream about the car that never stops, while social media amplifies every successful journey, driving curiosity and demand to unprecedented levels. Meanwhile, industry resistance intensifies. Some automakers label the technology as unproven or experimental, while fossil fuel lobbies hint at economic threats if self-powered vehicles go mainstream. Patents are challenged in courts, debates rage about intellectual property rights, and Maxwell navigates a labyrinth of legal, financial, and technical obstacles. Every victory on the road is countered by behind-the-scenes pressure to slow adoption. Yet Maxwell's vision persists. Field tests expand to longer journeys, harsher climates, and heavier loads. The cars demonstrate reliability in scorching deserts, freezing mountains, and torrential rains, proving that the principles outlined in the patents are robust, not theoretical. Engineers continually optimize energy capture and conversion, making each vehicle more efficient, safer, and easier to produce. Observers realize that what once seemed impossible is steadily becoming inevitable. Public fascination shifts into cultural significance. Children draw the cars in schoolbooks. Tech conferences host panels on self-powered mobility. Governments explore policies to integrate these vehicles into national transportation networks. Even the energy sector starts acknowledging the inevitability of change, with some forward-thinking companies investing in Maxwell-inspired research rather than resisting it. At the heart of it all, the cars keep moving, silent, efficient, and unstoppable. Each journey becomes a symbol of human ingenuity overcoming limitation, of a technology that refuses to be constrained by convention. And as Maxwell's blueprints inspire a new wave of engineers, innovators, and dreamers, one thing becomes clear. The self-powered car is not just a vehicle, it is a movement, a glimpse of a future where mobility is free, energy is optimized, and human potential is boundless. The world reaches a tipping point. Self-powered cars, once a bold experiment, begin appearing in cities, highways, and remote villages alike. Governments start incorporating them into public transportation. Corporations pivot to embrace the technology rather than resist it. Streets hum with vehicles that never stop, never refuel, and never plug in, silently rewriting the rules of mobility. Maxwell's vision, once contained within the pages of U.S. patents, has become reality. Communities gain freedom, industries rethink their models, and the very concept of energy dependency begins to fade. What was once impossible now moves steadily across continents, proving that innovation, persistence, and daring ideas can change the course of history. As the sun sets on a world in motion, one truth stands clear: mobility without limits is no longer a dream. It is here. And it all started with a blueprint, a bold idea, and a car that could power itself. The future has arrived, and it never stops.